What we're doing is we're taking supplied adhesives that come on a roll stock, and we were aligning them on a prototype assembly fixture so that we can align the plastic component to the actual adhesive to encourage accurate placement and then to later encourage full adhesive bond. What we're doing with that cleaning device on the side there is that the client has expressed an urgent need to minimize the amount of contaminant on the surface of the pieces. And while we're assembling in an ISO Class A clean room that is a certified clean room, there's always a chance for some surface contamination to build up due to static electricity and things that are in the air, especially during this time of year. It's winter right now here, so the air is very dry. And the parts get statically charged when they go on the conveyor or when they touch one another, so you run the risk of having any particulate in the environment that does exist as allowed in the ISO Class 8 standard. You run the risk of that contamination being drawn to the plastic components because of static. So we have an effort there to just remove any static electricity from the parts. That part washer is not just an air blast, it is also a deionized air blast, so it actually removes the static from the parts. And then also cleans off the parts at the same time with a source capture filter in the back of the device to make sure that any particulate that we remove from the parts doesn't just get loose in the environment, actually gets trapped into the filter. The client is coming to us with an existing assembly line that's overseas, and what they have currently is a Tyvek pouch. And there was a lot of complaints from the field about the usability of the Tyvek pouch and the ability to remove the product from the pouch in the field. So what we decided was to redesign the entire user experience from the ground up by replacing the Tyvek pouch with a Tyvek sealed thermoformed blister. And what we see in that last part of the video is operators taking assembled product, prototype product, but assembled product, and placing it in the correct orientation inside the blister, applying a Tyvek lid that is just loosely placed and located in a sort of a fixturing device that's inside of the blister sealing machine. And then once all 6 cavities are filled with blisters, product, and lids, the initiation button is activated and the drawer goes into the machine, at which point a heated platen comes down and encourages a bond between the Tyvek lid and the thermoform blister. The clean room ensures, so this is for use in a, like I said, it's an assisted reproductive technology device, meaning that this device helps to isolate the strongest sperm from any given sample. So if you have bits of debris and particulate in there, you're actually interfering with what the intended purpose is of the device. So it's important to us and to the client, obviously the client, to make sure that we minimize any sort of surface contamination or debris that may get included into the fluid pathway that we create in the injection molded components. So the user experience of the blister is kind of it's a very exciting development that we've embarked here on Natech. It's the first time I've ever had to design a thermoform blister from the ground up. And the design inputs of a blister were sort of foreign to me, so I guess in order to get a handle on what that looks like, I work with some very good suppliers that are all domestic based, and I found 2 really strong suppliers that helped me understand the design requirements of their process, and not just like give a man a fish, but actually teach a man to fish, which was great for me because I imagine that as we get further and further into the medical device industry, that I'll have to make more blisters, and now I have this knowledge base, which is pretty exciting. And the overall user experience was cool too because by going away from a Tyvek pouch and toward a blister with a Tyvek lid, the user experience changes dramatically. So right now what the user is required to do is to either, on the Tyvek pouch, to use a scissor to cut the lid off or an edge off or something, or they can use the sharp edge of the product to sort of pierce it through, and it's kind of rugged and it's not really great. It gives the user the impression of it's the opposite of an engineered solution, an unengineered solution. And what the blister allows us to do, the blister with the lid, is number one, the blister lid has artwork on it that indicates to the user where to begin the initiation of the peel process from. And then number two, we have a very high degree of control over the amount of bond between the Tyvek lid and the blister package itself, so that we can almost custom make the user removal experience, which is a big deal. When you buy a high-end product for a medical device, you want to make sure that you're getting the best you can for the money you're spending, and it's important from an overall quality perspective and from a seal integrity perspective as well. for seal integrity is number one for this client, because this device is sterilized after we manufacture it here. It's important that the seal is integral into the overall device, and that that the risk of puncture or piercing of the seal is minimized, which our blister accomplishes with flying colors, and we're very excited about that.